Restoration means having confidence that we're going to give our children a safe climate, that they will survive. If we wait till 2080, so many ecosystems will have collapsed. So many political systems will have collapsed. 20 or 30 years ago, no one was talking about 50 Celsius or 120 degrees, in the Middle East. The effects of the Pinatubo eruption removed almost 20 gigatons of CO2 in 1 year. We did research earlier this year showing that there were two other eruptions, one in 1580 and one in 1815. People don't listen to the cops, they talk. The context of geoengineering is you're going to try something that'll destroy our planet. The method, of course, is using iron dust in the certain parts of the ocean. The cost looks like it'll be $1 or $2 billion a year total for the whole planet,
Which is nothing.
which is nothing. We could ask ExxonMobil to do it, and in fact, if we asked them, they certainly would.
Hello, everyone. Welcome to another episode of Science Talk. I'm your host, Dr. Mohammed Itefak. I go with my first name, Mohammed. In this episode, I'm very excited to talk to my guest today who believes that we can leave safer and healthier planet for our children. Peter Fiekowsky, who is an MIT graduate, author of a book, Climate Restoration, The Only Future That Will Sustain the Human Race. Physicist and entrepreneur and a social innovator. He has also worked at NASA. He holds 27 patents. He pursues a mission where he wants, quoting, to leave a world we are proud of to our children, unquote. Peter, welcome to Science Talk.
Mohammed, thank you. I'm honored to talk with you and your audience.
Thank you so much, and I hope I introduced you correctly. So let's talk about. You have explained a year ago, I believe, on Dan Miller's Climate Chat, what is climate restoration, and I'm gonna add a little bit into that. That like we always talk about these big issues that we are emitting more CO2, we are warming the world. But there are terms, which are important to explain and know what do they mean, and that is climate restoration. And I want you to explain that. And also, like, what is mitigation and adaptation? Because we hear a lot about mitigation and adaptation, but we don't hear much about restoration.
Yeah. Well, climate restoration is defined as leaving our children with a safe CO2 level like we were given. So it's that simple. And doing that by 2050, which is an arbitrary date that we picked because it just seems like it's not too late. If we wait till 2080, so many ecosystems will have collapsed, so many political systems will have collapsed. It seems like we might fail, but by 2050, we can do it.
And it's how is it different than mitigation or adaptation?
Well, mitigation means not making it worse.
Hmm?
Adaptation means, well, it's going to be bad, but we'll adapt to it. Both of those are good things to do. That is, the world is always changing, so you always have to adapt to a changing world, to erosion, to new species, to new technologies, to new philosophies. Adaptation is always critical. Um, and climate restoration is putting a stake in the ground and saying, we want the future to go this way. And when I started work on climate restoration, it took me a long time to figure out what is it that we really want in the climate? Because we usually ask, uh, what can we tolerate?
So you admit that, these systems are changing. Some are with rapid pace, some are like slower than the others. And why is it better to have a restoration than adapting to these changes?
Well, restoration means having confidence that we're going to give our children a safe climate, that they will survive. Adaptation means, well, we'll see what happens and we'll do the best. We'll muddle through. If we go extinct, well, that's what happens. So this is taking a stand that we're not going extinct. We're not going to even suffer. We're
Mhm.
actually going to have agriculture and civilization flourish again.
And it's better, according to your solutions and philosophy, it's better to restore instead of just adapting because yes, we're not adapting, but like maybe our future generations would adapt, but we don't know if they're gonna adapt it to or not.
Yeah. Well, humans will always adapt if we survive. And even if we don't survive, that's a form of adaptation
Mhm.
is collapsing.
Mhm.
So, yeah, it's really quite simple. People talk about climate repair, and
Mhm.
I
Yes.
always tell them, well, listen, if you're giving your child a Chevy, do you
Mhm.
want to give her a repaired Chevy or a restored Chevy? Right? Repaired means it's clunking along, but
Yeah.
it still runs.
Yeah.
Restored means it's glistening and it's inspiring, and I think all of us want restored.
Mhm. So there are two timelines. One is what nature has a timeline, right? For
Yeah.
nature, the systems, meaning 1 million year might be, just a few seconds within that system. On the other hand, for us, 20, 30, 40 years are a lot, right? Like how we rationalize the time for ourselves as humans. So why 2050? Why not 2080 or 2100 when you talk about climate restoration?
Well, as I mentioned, by 2080, most people's intuition is our planet's going to be pretty intolerable.
Mhm.
We don't know for sure, but that's just the intuition that most people I talk to feel. And that's just too late. So
Yeah.
by 2050, most people have a feeling like we could be okay. And in fact, if we get CO2 back to what it was to safe levels by 2050, that means that by 2040, CO2 levels will be back to what they were 20 or 30 years ago. And 20 or 30 years ago, no one was talking about 50 Celsius or 120 degrees, in the Middle East. That wasn't ever mentioned 20 years ago. So getting back to that point by 2040 is quite viable.
So isn't that like we have to have a net zero by now if we want to get there by 2050?
Well, it depends on how fast you go. And so we'll talk, I'm sure, a little bit about the methods. The interesting thing, a very important data point is after Mount Pinatubo erupted in 1991, in 1992, we had net zero, which means that the effects of the Pinatubo eruption removed almost 20 gigatons of CO2 in 1 year. That's how much CO2 we emitted in 1992 was 20 gigatons, and CO2 levels didn't go up that year. And so that tells us that this accidental thing, not unengineered, was able to do that. And so we probably can, based on that fact, it is good argument that we could get out any amount of CO2 that we want when we decide we want to do it, which hopefully will be in the next few years.
You mean like if we decide we can remove this amount of CO2 from the atmosphere, we can.
Yeah, when we decide we want to, because it's been demonstrated. And so once things are demonstrated, then it's just a matter of intention.
And do
And
we want to? Like, I mean, like in terms of looking at the people who are going to do it, because it's not individual thing we can do it, right?
it looks like it'll take a crew of 1,000 people or so involved. But finding 1,000 people who want to do it will not be difficult once the concept becomes available. Like, oh, we actually could do it.
Mhm.
Because I know the way I felt 20 years ago was it was hopeless. If we could restore a safe climate, we would have.
Mhm.
Since we haven't done it, this is
Yeah.
2020, 2005, my brain figured it must be impossible. Because if it were possible, we would be doing it already.
Yeah.
And it wasn't, it took me another 10 years before I realized, no, it is possible, but no one has discussed it. And so everyone assumes it's impossible and doesn't even discuss it.
So the way CO2 works, once we emit, it's gonna stay in the atmosphere for hundreds of thousands of years, right? And
Unless,
and some people argue that it's the way you're presenting it, it seems like an easy thing to do. But when I talk with Dr. Peter Kalmus, he said, like, I think in Netherlands or some countries tried to do it, and it took 1 year to remove 1 second's worth of CO2 what we emit to the atmosphere, and it took them 1 year to remove that much. So how do you remove this much carbon emission? Because yes, we
yeah.
want it a little bit over there. It's not we want to completely remove and we go to back to ice age, but we want to keep a healthy, safer existence for our humans and other ecosystems and our other species. So isn't not that complicated or like too much time we need to remove this much?
Well, I like your quoting Peter Kalmus, and I haven't spoken with him yet, but I will.
Yes,
And
I'm gonna send an email after the interview. So
perfect.
yeah.
So he's thinking the way I was thinking 10 or 12 years ago,
Mhm.
which is that when I first was introduced to global warming back in 1975, when I was a sophomore at MIT, um, I figured, well, we know how to get CO2 out of the atmosphere of the Apollo spacecraft and out of submarines. And so I imagined we would do the same th process to get CO2 out of the Earth's atmosphere. It would be difficult, but totally doable.
Mhm.
And that's what I thought for decades while I was doing other things. And then when I got serious about restoring the climate, I was still thinking that, as I think Peter Kalmus is still thinking that. But in the meantime, right around 1990, science figured out how do ice ages work.
Mhm.
And once we had the ice core data from the Antarctic, then we realized, oh, here's the CO2 levels go up and down by the same amount that we need to remove right now. And so wasn't until almost 20 years after I first heard about global warming, and probably Peter's roughly the same age as me. Now he's younger, but
A little bit younger, yeah.
yeah. Um, and so it was years, into decades into the global warming issue that we realized, oh, wait a minute, ice ages have already done it. But
Mhm.
it was sort of too late, and our physicist mindset was set in concrete. And somehow, because I wasn't doing climate, I was able to break through and say, wait a minute, let's do the same thing nature does in ice ages. And in ice ages, as I said, nature removes vast amounts of CO2, and it does it with photosynthesis, which is no surprise because sunlight is abundant. In the ocean, which is no surprise because 70 or 80% of the planet is ocean. And it turns out when we look at the volcanic eruptions, as I mentioned, Mount Pinatubo removed 20 gigatons in a year. Now, you would think that that would wake up the scientific community because the official estimate of doing photosynthesis in the ocean says the maximum is 1 gigaton in a year, maybe three. And there's no mention of what nature did in 1992 of 20. Um, but the brain works in funny ways when
Yeah.
you've got a collective thinking. And so, really, it wasn't until the last few years that people have begun discussing what we call the Pinatubo pause of the CO2 increase. Uh, and so, when you do the numbers, it makes sense. There's plenty of sunlight. If you add the iron, because iron is the missing micronutrient in most of the ocean, once you now the limitation is once you add enough iron to get the photosynthesis to work, then very quickly you run out of nitrogen. And so then you also now have to add enough iron to get the nitrogen fixing bacteria growing. And that takes several months to happen. But when you provide the iron and the time for nitrogen fixing, now you've got the mechanism to get massive amounts of CO2 out, as demonstrated by Mount Pinatubo. And then we did research earlier this year showing that there were two other eruptions, one in 1580 and one in 1815, which also removed massive amounts of CO2 afterwards. One of them was 100 gigatons was removed.
It sounds like the way you're talking, it seems like we have the solution and we can do it, but we don't hear these things from media, from scientists, from any other climate reality, or a lot of other solution-oriented approaches either. Why is that?
I think it's sort of the Chicken Little conversation that no one wants to be the person saying the sky is falling or the sky isn't falling. It's too embarrassing, especially if you're a university professor. I'm sure you understand.
Yeah.
And so, fortunately, I'm not a university professor. I'm a semi Silicon Valley entrepreneur, and so I don't have to worry about my career. And so the challenge has been getting more and more people to discuss it so people will feel comfortable. The best examples, I went to one of the biggest environmental NGOs and their chief scientist, and he said, who likes me and I like him. And he said, Peter, don't talk about reducing CO2 levels because we don't know what will happen if we reduce CO2 levels. And I'm looking like that's weird because if CO2 levels go back to what they were 25 years ago, the climate will probably go back to that, and then the ecosystems will tend back there. And I was thinking, why would he have said that?
Yeah.
And the answer I can see is that the UN, the United Nations, their framework for climate change, their explicit goal is stabilizing greenhouse gas levels. And so, as the chief science officer for a major, multi-hundred million dollar NGO, he has to abide by the global goal, which is stabilizing. So he had to make up an excuse for why we shouldn't reduce it. But as soon as yeah, I think if I came to him uh, next month, he would have probably changed his tune already because there were enough people talking about it, including yourself. And Mohammed, you're making this conversation as a Harvard professor right now, or a visiting professor, I believe. Um, it's a big deal
So
to move
yeah,
the
I mean,
needle.
I think you're right. We professors sometimes forget how easy if every answer somebody asks a question and the first answer is 2 words, it depends. And then like like everything it depends. And sometimes like it irritates me. It's like, no, that's not what I want to hear. Give me the concrete solution or answer. But I think professors are not good dealing with uncertainties, but they're good spreading the uncertainties. Like we don't know what's gonna happen. It's like, the system. But the Earth's system, it's too complex. There are too many components into it. And CO2 feels like, or it seems that it's upsetting all of those systems in a varied degrees, right? So if we just talk about, CO2 removal, and one of the things you mentioned, and I want to ask you before, like, we have 25 years, and right now the scientists are saying that we already reached 1.5, 1.8 degrees. That's why coral reefs are tipping, and that's why it's not, we are seeing more and more negative or, sad news about our collapsing climate, planet.
Yeah.
But if we you said like we can solve climate crisis before 2050, but like the real question is, will we solve the climate crisis before 2050?
Yes. Yeah, I think that the breakdown happened around 1980, because right now we look at climate as science,
Mhm.
and science is designed to predict the future. If I throw a ball, um, science will predict where the ball will land, and
Based on the mathematics and calculations and modeling, yes.
right. But then, if a bird flies and picks the ball out of the air, the scientist gets very angry
It's like I
because,
did not calculate that variable into that. Yes.
right,
Yeah.
that's not fair.
Yeah.
Now, in 1961, when Kennedy said we're going to land a man on the moon, it was not predictable,
Yeah.
but Kennedy said we're going to do it. And tens of thousands of men and women lined up to make it happen and made it happen early. And the difference was it was created as an engineering project,
Mhm. Yes.
and as opposed to a science project, because of the politics of the
Or maybe
80s.
geopolitics, or maybe geopolitical decision to go land on the moon first. Yes.
Yeah, but it was managed as an engineering project, like
Mhm.
building a big house or
Yeah.
something. Building the Great Wall of China was not a science project;
No.
it was an engineering project,
Yeah.
civil engineering. And we've been treating a bit for political reasons. In the 80s, it got very politicized. And so the liberals said, okay, we're going to follow the science.
Yeah.
Because, rather than, the Reagan said, we're going to go free market. And there's something to be said for both. But science doesn't allow for innovation.
Yeah.
Right? Science is based on the past. Anyway, so the whole thrust now is shifting it to engineering that nature has shown us it can be done. Now we just have to engineer it. And that's a matter of intention and finance.
And and yeah, we're gonna talk about both. So you one of the methods you propose is that we it involves iron dust, right?
Yes.
Can you explain that? How does it work? And like how, yeah, explain that.
Yeah. So the way nature removes CO2 before each ice age, and we've had about a dozen ice ages in the last million years, and it's photosynthesis in the ocean. What the limiting factor, as I mentioned, for photosynthesis anywhere is iron. Of course, on the land, there's lots of iron in the dirt usually. In the ocean, the iron tends to sink. And so most of the ocean is blue
Mhm.
because there's not enough iron for photosynthesis to happen in the phytoplankton. And so providing a little bit of iron, nature does it in the form of dust storms. So a lot of us have heard about the dust storms that blow off off of the Sahara Desert across the Atlantic into the Amazon. And if you look at the Atlantic Ocean, it's very green in that band because the iron rich, that the pink in the Sahara dust, that pink is iron. And so it fertilizes the ocean and it's very green. The So it's a natural process. Volcanoes do it. Of course, when volcanoes erupt, the dust from the volcano, the ash, has a lot of iron in it. The trick, it turns out, what we've learned in the last few years is there are two other things required. You have to provide the iron dust. It has to be in a downwelling eddy to get the maximum output because when you get the phytoplankton, which is the base of the food web, when it grows normally, the fish eat it and they metabolize it, and eventually it all gets exhaled back into the atmosphere. In a downwelling eddy, it pulls a lot of that biocarbon down into the deep ocean where once it gets below about a kilometer, it stays for over 1,000 years. And so doing it in a downwelling eddy, there's strong evidence that's critical. And then the other thing, as I mentioned, is providing enough iron so that the nitrogen fixing bacteria, the
And that is
cyanobacteria,
that is artificially doing it.
or naturally, that is after the eruptions, there's enough.
But like,
Um,
how do we like do it? Because that's a nature cycle, does it automatically. It does, we don't control that. But here we are thinking like, if there's no enough dust storms, what do we do?
right, then we distribute the dust. The way it's been done in the past has been just go to I'm exaggerating, but go to the hardware store, get a ton of iron fertilizer for your yard, and distribute it in the back of a ship.
Mhm.
That's almost, they do it more sophisticated, but it's the same chemical that they use. Probably there are more optimal chemicals, but it's complicated. So at the moment, we can't say too much.
Okay. And the other thing is that the direct air capture method. And you said like we other maybe have other carbon tech to remove CO2. What are those?
Yeah, so the ways that we physicists and engineers have been thinking about it, one is direct air capture, which is the method that's used in spaceships and in submarines. And basically, you use usually an ammonia compound, a basic compound, which will attract the CO2, which is acidic. And then you use some method to sequester the CO2 afterwards. Uh, it works. It's been working for 100 years, but it's complicated and expensive. It requires a lot of energy. There are other methods. For example, there are a large number of other methods. There are people now who are taking detritus from forests. So cut down old trees and then they'll sink them in the ocean, right? Because once you get below 1,000 feet or 1,000 meters, there's not enough oxygen, and those branches and trunks will stay they won't rot. But the trouble with that, again, it requires a lot of energy and a lot of effort, and the scale factor is wrong by about a factor of a million, and a million is a lot, and 1,000 is a lot. A million is 1,000 thousands. It's
Yeah.
just out of the question. So to put it in context, the leaders for direct air capture, their goal is to capture about 1% of global emissions.
Mhm.
And so, it's off by a factor of 100 of emissions and another factor of uh, 2 or 10 in order to get CO2 levels down.
So do you attend the COPs to talk about these things with other leaders or policymakers?
I have in the past. I'm not going this
This
month.
year. Okay.
But the trick is to get the interest,
Yeah,
and people don't listen to the cops; they talk,
that's true.
and
That's true.
and
Yeah.
so no,
Yeah. Hey, I'm just gonna say like, hey, cops people, if you're there, just listen this year. Do not talk.
yes, yes, yeah. Listen for what you want.
Yeah.
That's the key thing is we grew up as children, and I don't know what it was like for you, but when I was a child, it was like it wasn't what do I want, is what can I expect?
Mhm.
And so I don't ask for too much, ask for something that I think I might get. When
Yeah.
it comes to climate, it's time to change and ask for what we really want, which is to give our children the same climate that we were given.
Yeah, and I think Dr. Peter Kalmas said on that, he said like we are having the party and our children are gonna pay the bills. So it's like that, and we don't want them to pay the bills. We want them to have a party as well. That's this Peter is proposing. And one of the things is that people, some people do talk about it like geoengineering, and it just kind of freak people out.
Yeah.
Why is that?
Well, because the context of geoengineering, it got framed as these genius kids trying something. And
Mm.
people tend to think about that story about they had problems in Australia with certain pests, certain insects or something, and they brought rabbits. And indeed, the rabbits ate, I think the rats. I think some rats came from the ships, and then the rabbits came to eat the rats, something like that. That's
Oh.
wrong, but it's close. But it caused the ecological disaster in Australia. And so the context of geoengineering is you're going to try something and it'll destroy our planet.
Oh, it might go wrong way, and you don't want to do that. We can't afford that because there are too many people on this planet already. So
Exactly.
most of your solutions are physics-based solution. Is that correct to interpret?
Yes, and I would say engineering based.
Engineering-based.
Yeah. So, when I wrote the book about 4 years ago, I've got another book in process now where we're just focusing on the ocean fertilization
Oh,
because what we've seen, 4 or 5 years ago, we thought there are other options. Um, but now there's no other option because we just don't have time.
yeah,
And we've learned a lot more in the last few years about ocean fertilization
yeah.
to realize it's been demonstrated to go at 20 gigatons a year without engineering. With engineering, we can probably do almost any speed we want. And we actually have an answer, which is initially the speed we want to reduce CO2 is that we want, temperatures have been going up at a certain rate. If we go down at the same rate, that's probably a safe rate. We might be able to go faster, and we can figure that out later.
And on your website, I would definitely recommend people to check your website, peterfiekowsky.com. Is that
Yes.
.com? Yeah, yeah. So please visit that website because he has a lot of good small handouts like this one, which reads like, what is climate restoration and can we really do it? And it's literally answer a small question. Where are we now? What is safe climate? So all of these details are like critically important to understand at 101 level talking about climate restoration. It is just not like the solutions. Like I think the some of the things which I really admire what you're doing is that you do not only figure out what we want, but also how do we achieve that. And that is a key element because some of the times we say like, oh, we want, healthier, safer planet, but like when you ask a second question, how? It's like, well, I don't want people to eat meat. And like, I don't want you to buy another shirt or I don't want you to have another laptop, right? So we talk about these things, but we don't talk about like removing CO2 with nature methods and like we have the solutions. But what is the cost of it? Is it too costly? Because if one hurricane hit California or one wildfire happens in California, it's hundreds of billions of dollars are gone. If
Yeah.
one flooding hits your area or one, cyclone or, typhoon, like all these things, it just kind of destroy the community's lives, kill people. And the cost of that is too much, but we don't realize it. But what is the cost of this, what you're proposing? Is it too costly, too expensive, or is it like manageable? And if government spend, like maybe 1% of the GDP, we will be better off.
Yeah. Well, it's even better than that. So the the method, of course, is using iron dust to in the certain parts of the ocean. And the cost looks like it'll be $1 or $2 billion a year total for the whole planet,
Which is
eh,
nothing.
which is nothing. Yeah, it's a like a thousandth of a percent
Huh?
of the global GDP.
Yes.
And so the good news is it'll probably not be done by governments because governments are political and the right is fighting the left. But it'll probably be done by individuals and corporations led by heroic women and men who say, I'm here for the future. And I'll put a little bit of money into doing that.
And can we ask like ExxonMobil to do it?
We could ask ExxonMobil to do it, and in fact, if we asked them, they certainly would, because imagine what how proud they would be to say, we funded restoring safe CO2
Yes.
levels for
And
all
then
of
they do all
humanity.
the greenwashing based on that to pollute the environment more. But yeah, I mean,
Well, the
uh,
thing I always have to point out that Exxon doesn't pollute that much. It's those of us who drive our cars and go to the Exxon station. We're the one who are burning it, not
but we
Exxon.
don't want to take the blame, right? It's easy to blame
Right.
others than taking the blame. Uh,
Exactly.
so the California is, I heard, or like maybe read, it's 100% renewable energy, right? And of course,
Occasionally.
occasionally, it depends on the weather conditions. So
Yeah.
California is, very progressive. They care about climate, and they have passed that resolution, climate restoration resolution in July 2023. Um, what are they doing since then? It's almost 2.5 years. What have they done after they passed that, or it's just become a piece of legislation and that's it?
Yeah, it was just a piece, it's messaging. There's no commitment to act on it, which is fine. Because as you said, you right now, most scientists aren't yet talking about climate restoration. So the purpose of it was to get people talking about it. We had there's a school group up in Napa, California, that had their member of Congress, Thompson, introduced almost the same bill into Congress 2 years ago, and then again this year. And so it's an opportunity for people to go to your member of Congress and say, please co-sponsor this, please put your name on it, and then it gives us an excuse to discuss it.
So is it a more of a symbolic than like
Yes.
something actionable?
It's
Uh,
symbolic.
okay.
Symbolism is very important.
Absolutely. And when it comes to, actions and then climate change, absolutely. So the four you call like quote unquote big four solutions that can restore our climate.
Mhm.
Uh, can we talk about them? And I mean, you
Well,
have them on your website, but just explain for the audience.
yeah. So again, I should remove some of them from my website or change it because, as I said in the first book we talked about the big four. Really, at this point, uh, well, and the big four. The first one is ocean fertilization, which is what nature does. The
And that's the
second
book,
thing.
well, that's the book which you're writing about now.
Yeah,
Yeah.
and then the new well, and the new book is just focusing on the ocean fertilization. But just so people know, the other thing that nature does is limestone.
Mhm.
Limestone by weight is half CO2, and so there's several companies now that create limestone out of CO2 from the atmosphere. It's not easy, but it's doable. And then seaweed is another viable method. But again, the limestone and the seaweed are about 100 times slower and 100 times more expensive than the ocean fertilization. And so at this point, we're really discussing the ocean fertilization. And then the fourth one, which is on the table still, which is a separate issue, which is methane.
Mm.
That once we realize that we can restore safe CO2 levels by ocean fertilization, and I got very excited. This was in 2019. And then it was just a month and a half later, we actually did a program at the UN about it. And then a month and a half later, we get these reports from the Arctic Ocean that these massive methane bubbles were coming out of the seafloor in the shallow continental shelf because the permafrost was melting because the seawater was getting warmer and the frozen clathrates, they call it, but it's frozen methane under pressure was beginning to melt and the methane was coming out. And there was a good chance that that would become a catastrophic extinction event. And I and my team looked at what can we do about that? And of course, we said, well, can we restore the Arctic ice? Can we capture the CO2 when it comes out? And the answer to each of those is you might be able to, but it's probably in the 1 or 2% likely that it would actually work, given the politics and the chemistry and so on. On the other hand, we found there was a wonderful solution that nature does already, and that's what's called atmospheric methane oxidation. So by enhancing it, it's called enhanced atmospheric methane oxidation, EAMO. Uh, we can actually oxidize the methane as it comes out from wherever, either be it from the permafrost or from even drilling rigs and from rice fields and so on, and from cattle.
Yeah.
So that's another approach. I don't discuss it too much because the first step is to get people committed to restoring CO2 levels. And
Yeah.
at $1 billion a year, once that tipping point is happening where people are going to start funding it in the next year, it seems.
And I think, or maybe if not ExxonMobil, maybe Bill Gates can do it since he's also, saying things differently these days about climate. Uh,
Yes.
so a couple of things, just so you, but or you believe that what we're doing to the environment is not sustainable, and majority of the things we are doing, a human activity, is accelerating climate change. And are you like kind of involved in any way, shape, or form with the climate project at MIT? Because they are doing some of the exciting things too with that project.
Um, well, I recommended to them that they focus on climate restoration and they put together a mission to restore the atmosphere, which is very exciting.
Yeah.
It's been almost 2 years and they're gradually getting the program together. It was more difficult than they thought it would be,
Yeah, of
but
course.
I understand because it's a brand new field. And
Yeah.
so there are no professors who
Yeah.
are working on it yet,
Or
but that's
money,
beginning to
because
change,
you
or
need
money.
money, you need a grants to do all these things, and maybe there are not many dollars into that yet. So normally, if you're in a business of like this, proposing solutions to fix something like a bigger problem, there are ideas, there are things, but you need money to do that. How do you keep up? Like, these ideas are great, all these things are great, but you also need to put food on your table. So like, how do you like kind of make money out of these? Like, what kind of things your organization or you do were like doing other than coming up with studies and proposing solutions and doing things, but like these things are not going into the market yet to test them out.
Yes. Yeah, well, that's a really important question. How do you fund climate restoration?
Yeah.
And you know, originally I thought what I think most people still think, which is you have to have a product that you're going to sell.
Mhm.
Sort of
Yeah.
like in order to create the climate problem, the companies had fossil fuel to sell, and it increased the CO2 level. It
Yeah.
warmed the winters, and people in Northern Europe sort of liked that. Uh, and then people ask, and I ask, what's the opposite? I've come to the conclusion that doesn't work.
Yeah.
That what you end up with at this point, trying to sell a product that removes CO2 is you end up with greenwashing, with people just doing
Yes.
things that don't
Yeah.
really make a difference.
Yeah.
Instead, we're promoting. selling it as branding.
Uh-huh.
So as you said, maybe Exxon would fund it, or Exxon would get together with IKEA and Apple and seven other companies to fund it. And then they can brand themselves like, oh, we're actually restoring a safe climate.
Yeah.
And so rather than selling a product, they're selling branding. They're
What they call the
selling
corporate
belonging.
social responsibility, CSR.
Yeah,
And do
yeah.
you, and some people might take that issue with that, like, oh, you taking money from these corporations are responsible at the first place. How would you respond to that?
Well, the
I mean, just if it's
yeah,
if it happens, like I said, like,
yeah,
oh, you know what, I have this idea, I have this thing, and I pitched to many people, nobody's taking it, but finally Microsoft or Apple agreed to do it. And then
yeah.
people would say, like, oh, what? What are you doing? Have you lost your mind? Like, look at these companies, their carbon footprints, what they have done to the climate, and you're taking money from them.
Yes, yes. Well, yeah, we're all humans. Most of
Yeah.
us all have children and
Yes.
likely grandchildren, and they care. And so the what we look at as providing a road pathway for
Mhm.
these individuals and companies to actually restore the climate
And,
because
and and I think if we can make them do it, why not, right?
exactly.
Yeah.
Exactly. Because one of the interesting things about the brain is we think that I get committed and then I take action.
Yeah.
But inside the brain, what actually happens is when you take action, your brain figures you must be committed.
Yeah.
So that the first time you go out to exercise, you know, you force yourself to.
Yeah.
By the fifth time, your brain says, "Oh, I've been going out every
Yeah.
day for the
Yeah.
last 2 weeks. I must be committed." And
Yes.
so actually having them take action develops the commitment. It's sort of backwards,
Yeah.
but it really does work that way.
Yeah.
And that's why when you get political requests for political contributions, they say, "Will you contribute $1?" Well, once you've contributed $1, your brain says, "I must be committed to that."
Yeah. And one of the things I heard you saying that, and you said it in this episode too, or interview, that like governments are too busy fighting wars and other issues, and they're not gonna think or do much about climate change, and we need to do it because we care about, our children, our grandchildren. Do you think we have to have something other than children or grandchildren to be committed or have a motivation to do it? I mean,
The,
that's a big factor. I mean, the children is a big factor, but like I just want to like hear your
yeah.
thoughts, like if there are some other things we can think of in this message.
Well, it's certainly culture. So as the Arctic melts, all these Inuit cultures, all these Arctic cultures are disappearing because their environment's going away. And so, and we miss that, because
Yeah,
it's wonderful to see these different cultures.
yeah, absolutely. And the second last question is, are you techno optimist?
Am I a techno optimist? I you could call me that, but I think of a techno optimist as someone who's hoping the future will be good.
Or
I'm
hoping that technology can solve our problems?
Yeah, I'm more of a commitment optimist, that those of us who commit to a future that we want,
Mhm.
that will do it.
Awesome. So the last question for you, which I ask every one of my guests, is that what is something you think we are not talking much about climate change and we should be spending more time talking about it?
Something about, well, the thing I
Like
want
we,
people
we are
to,
not spending as much time as we should be spending on that.
yeah, yeah, I want people talking about humanity flourishing
Hmm?
for millennia to come. It's an idea that I think almost everybody loves once they visualize humanity flourishing. Civilization has been going on for 5,000 or 10,000 years. We could have it continue for another 10,000 or even a million years, but we have to plan on it. We have so much technology now that if we don't plan on humanity flourishing, it's going to become a mess as it has become.
Yeah.
Once we plan on it flourishing, we will deliver.
If you don't plan, your day will be a mess. So it's the word. So you have to plan, otherwise it's not gonna work. So thank you so much, Peter, once more. I think we have to leave it there, but I would like to have another episode with you on your new book, which is coming out about ocean fertilization. I'm really excited about to hear more about that. But maybe once the book is out or near finish draft, we
Yeah,
can talk more about that. But I will send an email with like putting you in CC and Peter Kalmus to hope to both of you to connect. And I think maybe at one day we can have another episode of Science Talk, both Peters together.
but
Uh,
that'd be great.
so thank you so much once again.